Hello, everyone. Welcome to the Scratch Olympiad 2021 final stage. I am happy and thrilled to see you all here. And today's translation is going to be quite an interesting one, quite an eventful one, because we are going to discuss what is going to happen during the final stage. What are the final stage tasks, how you can find them, where you will submit them, etc., etc. I will announce a special surprise for our guests, as well as 3 amazing workshops from the teachers of Robbo. But that will happen at its own time. For now, I would like to introduce you to the CEO of Robbo and the chairman of the Scratch Olympiad Committee, Pavel Frolov.
Hi everybody, my name is Pavel Frolov and I'm founder of Robbo. And I would like to congratulate everybody who is participating in our final stage of Scratch Creative Programming Olympiad. In Robbo, we are very excited to support Scratch Creative Programming Olympiad, and also I would like to say that here in Robbo we have 3 offices now, and one office is in Russia, where we have best coders in the world, second office in Finland, where we have best education system in the world, and third office in Japan, where we have best robotics engineers in the world. So we are working hard to deliver best education robotics product in the world, and we would like to be partners with the winners of International Scratch Creative Programming Olympiad. So welcome to our final stage and good luck.
Thanks a lot, Pavel. So right now, I would like to give you some information about the final stage of the Olympiad. If you're a participant, you would be especially interested in this part because right now we have published the tasks of the final stage of the Olympiad on the creativeprogramming.org, the website of the Olympiad. In the chat of this translation, you can find the links to the tasks of the Olympiad, to the title page of the Olympiad. What do you need a title page for? For a creative task. Every and each creative task of the Olympiad has to have a title page. And this is where you can find it. Like, the links is in the comments to this translation. It will also be published on the Facebook of Scratch Olympiad, and you can always find it on the website of the Scratch Olympiad. Don't forget to insert the title page into your creative task. You can also find a link to the quiz, but about that later. Let's first figure out how you should do the task for the final stage. Once you go to creativeprogramming.org and press tasks of the final stage, you will see a list of nominations and disciplines. As you, of course, know, Scratch Olympiad has 2 disciplines, Scratch discipline and Scratch+Robbo discipline. So you need to find your discipline, and then in that discipline, you need to find your nomination. So for example, your discipline is Scratch and your nomination is Scratch Kit. So you need to find that in the list of nominations, press it, and you will see 4 links. The first link is your I think it was an algorithmic task, the first one. You need to solve an algorithmic task you need to solve a creative task with the title page in it. And you need to solve a general test on the knowledge of Scratch. What is the fourth link? What is the link number 4? It's a link called Submit Your Project. And it's the only link that you should use to submit your project. Basically, once your project is done, you click that link and you will be forwarded to a Google form. You fill in that Google form, you attach your project, and basically you press submit, and that's it. You wait for the results. About the results for the Scratch discipline will be available on October 12th, as well as for Scratch+Robbo discipline. But to complete the task, you will have the Scratch discipline, guys. You will have 2 days. That means that on September 27th, 2021, at 9 a.m. UTC, all the tasks and all the links will close for you. If you are a Scratch+Robbo discipline participant, this deadline for you is October 2nd. So Scratch discipline, September 27th, Scratch+Robbo, October 2nd, 9 a.m. UTC. Please check the right time for your country. So when will you find out the results? Everyone will find out the results on October 12th. We will publish them on the Facebook and send your certificates via email. What else? We have a special surprise for our guests, for the mentors of the participants, and everyone who is interested in Scratch and thinks that he or she knows quite a little bit about the Scratch creative programming language. It is called an intellectual quiz, and you can also find it in the link. You can find the link in the comment to this translation. You can also go to the website and find the link in the list of links called Intellectual Quiz. Press it, and this is a quiz only for guests, not for participants. If you're a guest, then that's your link for sure. So you press that link and you solve a test on the general knowledge of the Scratch programming language, just, to test yourself, to test your limits. And you will also find out the results on October 12th. And if you did great, you will receive a certificate stating that you are basically a Scratch expert right now. So that's about all I wanted to share with you. As usual, you can always write messages in the FAQ section on our website. You can always write to our email account if you have any questions. But I hope you have fun doing these tasks. And right now, I would like to introduce our first workshop on robotics by Svetoslav Savelyev, an amazing teacher from Robbo. Have fun.
Hello everyone, and welcome to our masterclass. And my name is Svetoslav Savelyev. So, what we speak today, we speak about robot, and the main topic of our masterclass is dialogue with robot. So, and I ask some questions for you, and please type in chat in YouTube if you have answer to my questions. So, let's go. First, my questions: what we use to communicate with each other. So you know some kind of languages. Yes, for example, I speak with you now in English language, and you know some kind of English. And please type in chat how many languages you know. And when we speak with each other in the same language, we understand maybe some kind of minds, some kind of words, and we can do some actions with it. For example, if I want a tea, so I can say to you, please give me tea, and you understand me. You maybe give me tea, maybe not. So, and the main topic of today is about robots. So how we can speak with robots, because I know a language, you know languages, but robot do not languages. And the next my questions: what we do if we don't understand another languages? So what this means? We have many countries, and in every country we have one of the languages. Yes, for example, if I want to speak to you and you live in France, more maybe I need to understand you, and I need to learning new language for me. And this is the way how I can speak with you. Or you can teach my language, and after that, you can understand my language. And this is the reason why we speak, for example, now in English language, because this is the most popular language in the world, and many of people know English language. And these people maybe know this is language very good or not, like me, for example, but we can understand each other. And this is the good way how we can communicate with many countries, with many people. But what is the robot? How we can speak with robot? So before robots was created, human people create computers. Yes, and the main questions with computers: how we can speak with computer, because computer do not many languages, but we speak with computer with logic, and we have special logic. And for understanding, we create new languages. We create special programming languages. And if you want to speak with computer, you use these programming languages, and after you maybe type some words in the special programming languages on your keyboard, you can push enter, and after that you can see answer of your computer. And this is the way how you can speak with computer, how you can give command to this computer. But for example, in computer languages, not so easy, because we don't have one computer languages. We have many computer languages. You know, maybe C, C++, Python, maybe Java. So you can type in YouTube chat what your favorite computer language, and how you can program in this language, and maybe how many projects you create on these computer languages. But robot, this is, I think, type of computer. Yes, because inside robot you have some kind of microcontroller, and you can communicate with this microcontroller. And this microcontroller can, after that, give some commands to sensors and give some information from sensors, because we have languages to speak with each other, but how we can give information from environment. So for example, I can see, yes, I have my eyes and I see information around, and I have my ears, and you see this is the headphones. Yes, and when you speak, I can listen you, and only after I listen you, I can take this information and make some actions after that. So, and the computer don't have, I don't know, ears, maybe eyes, maybe other interesting things, because he have only processor. But robot have sensors, and these sensors is look like our feelings. And The easiest way to speak with robot now, and you go to the Scratch Olympiads, this is the Scratch language because it's easy to understanding for you, for robots, and we create some kind of special blocks to programming robots. And with these blocks, we can speak with robots. And today, I try to show you one of this language on Scratch. So let's start. And of course, I see you answering. So cool, Python. Okay, so let's start. Now I show you first one. This is Scratch, but not simple Scratch. This is Robo Scratch. And in Robo Scratch, you have special blocks. For example, you can special blocks for robot, and we will use these special blocks for robot. Of course, we will use all blocks in Scratch, not all today, but the many of them. And I can show you robot. So I have another camera here, and you can see robot, a robot in my table. So this is my hand, and I can, yeah, I can touch this robot. So this is Robo platform, and this is Robo platform have some kind of wheels, and I can connect to this Robo platform some kind of sensors. I have three sensors for today, and I will show you what we can do with these sensors. But first of all, how we can create dialogue with robot. For example, how we can create dialogue with each other. I can ask you questions, and you can answer to my questions, for example, I don't know, something. And after you say this, I can listen you're answering. And after that, I can say, okay, that's right. Or maybe, no. Mm-mm. And now I create the simple program which show you how we can speak with robot. And I create a question, simple question. So let's hide this screen and first of all create program. Of course, we create program with our favorite block. So you know this block. This is green flag clicked. And I will zoom. Yes, when green flag clicked. And we create some kind of question. So simple question. I go to sensing and ask. So this is simple questions. How, yes, many paws have a cat? And questions. So you can type in chat on YouTube how many paws have I don't know ordinary cats. So the most cats in the world have the same number of paws, I think. So after that, I can answer on these questions. Yes, you know how. So we can click on green flag, and this is RoboMan. Say how many paws have a cat. So I can answering, and I can using conditions for this answering. So I will using control and if condition. Yes, and here I have two actions. Yes, maybe correct, maybe not. And these actions I will give for Robo platform. So, and what Robo platform will do if we can say correct answer. So I go to robot. Yes. And if we have incorrect answer, robot say, mm-mm. So that means robot go right, left, and go to center. For this, I will use blocks turn. And I can turn for any degrees, for example, 50 degrees, but I will do more than 50 degrees, for example, 30 degrees. Yes. After that, I can turn right and turn left for the 60 degree. I have another block. Yeah, this one. And here I can type 60 degrees, and that's one. So if you see how I see to this direction, this is my second monitor, and you see all information on this monitor. And after that, I can use turn right for the 30-degree. So, and this is disagree for robot. Yes, wrong, wrong. And I can put this in else. Excellent. So if we type correct answer, so our robot can do some actions. For example, they can yes, but robot don't have ability to do yes. They can it can move forward or backward, for example, and we create these actions for correct answer. So I can use it, and I will use for this special blocks motors on for one step. And here I can create, for example, 5 steps. Yes, 5 steps. This is steps. This is the smallest movement for robot. And I can move for 5 steps, but in each direction. For example, forward or backward, or maybe right, or maybe left, because we need create the most accurate command. And for this, we use another block. We use block set robot direction and set robot direction to forward. That's one. So what it means? We set direction, and after that we go forward. It's pretty easy because you know Scratch, you create many games, programming, or the other things. And for robot, it's very easy. So we can set robot direction forward. After that, motors on for 5 steps. After that, we can change our direction and go back. So how we can do this? We can just duplicate these blocks, and here we can change direction for backward. Boom. Yes. Excellent. And it's not so long. Yes, we go forward and backward. So we can create some kind of cycle, maybe do this 3 times. And for this, I can use events or not events or control. We can use repeat here and repeat, for example, 3 times. Okay. That's all. We create actions for correct and incorrect answer, but we don't know what is correct answer. And I see in chat, no one says how many legs have a cat. Okay, I can answer on these questions. I will use operators, and I will use equal, and we can type here 4 legs, for paws, for cat. And I go to sensing and using answer here. Yes. And put this thing here. So now we create simple program how we can communicate with robot. Now without sensors, of course, but this is the way how robot can show us how it work. Yes, Tanisha, excellent answer. So I see. Okay, let's, yes. So now I see answer on these questions. Excellent. Okay, and I launched this program, but you want to see robot, and I show you robot. So how many paws have a cat? I can put here, for example, 5 paws and click enter. No, robots say no. Strange thing. Okay, let's do this again. How many paws have a cat? Maybe 6 paws. Enter. No, robots say no. Okay, third one. Click on green flag and say 4 legs. Excellent. Robots say yes. And this is the way how you can create your program. So we have information and we can use this information for robots. So what's next? Let's see how robot can take information from environment. And it will be really interesting because information from environment, this is the way how robot can communicate with our world, with our environment. So for this thing, I hide this robot and I delete, I think, all blocks instead of when green flag clicked. And now I add the sensor. So the first sensor which I can show you, this is the distance sensor. So I can show you video and you can see distant sensor. So this is the special sensor which can take information from obstacles, and you can see how far away these obstacles from you. So I can put this in the first place. Yes. And now robot have 5 special places for sensors. And in the first one, I put this sensor. So this is distant sensor. But how I can see information of this robot? So I can hide this screen and I can click on this button. This is special R indicator. So R, this means robot. Click on the left mouse button and you can see here all information which we can take from robot. So for example, we can path left, path right, and information from 5 places. So if we put our sensor to the first place, we can click here left mouse button and you can see numbers, some kind of numbers. And this is 18 numbers. So I don't know what it means, but we can take some obstacles. For example, box from this robot. I can put this box here and you can see information now is rising. So of course you don't see anything, but I can move this robot's information in this part of screen. After that, I show you robot and you can see the box. And if I can box this closer, you can see number is increasing. And if I go away, you can see number is decreasing. And we can use this number. So all information which we can take from robot, this is numbers. And we can use these numbers for creating some kind of program. So, and now we try to create some kind of program, how we can use this information. So, and the first one, we create program, how robot can move forward and stop before crash, I think, yes. For this one, we create easy program. And now when green flag clicked, we create the first condition for our robot. And what's important for creating? We need use block set motors power. And if we have 100%, that means we have all motors power. And if we have 0% for motors power, that means robot can stop. And for this one, I create 100% because we must start with the full motors power. And when we start program, we need go forward. Yes, and we use this block set motors set robot direction forward. After that, we create the forever cycle. Go to control and forever. And inside this forever cycle, we create, I don't know, set motors power. And here we must create some kind of condition which will use our information from this sensor. And for example, I can use operator minus. And in this operator, I can take information from the first sensors. So I go to robot and I use robot sensor 1. So, and this variable changes every time. And I can say minus, yes or not, here, minus. And here I can maybe 50. And this thing I put here. So what this means? We can set motors power 50 minus robot sensor 1. Robot sensor 1 will increasing, yes, and after that, all this variable will be decreasing, and robot can stop before they crashed. So, and the last one, we need block, which can launch motors on this robot. And I will use motors on here. So that's all, easy program. And now I show you how this program is working. So now you see information from sensor 1 is 20. And I show you robot. Where is my robot? here, and let's start. I click here. Yes, interesting. So let's try again. Hmm, robot is stopped. Okay, let's create another test. So I put robot here and this thing here. And after that, I click green flag, robot is stopped. So, okay, let's move this box from robot. Hmm. 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 So robot go forward and every time stop before this box. And this is the way how you can create robot, maybe which can follow for some kind of obstacles. And this is the only one way from many, many ways how you can programming this sensor and how you can create interesting programming interesting program for robots. But robots have not only sensors. So for example, I can now stop this program and instead of this sensor, I can put another one and I can put here maybe flashlight. So this is flashlight. I put this flashlight in the first place. And now when I put here flashlight, so I can move away this box. So, and when we put this flashlight, we can create program for this one. So you can see information from the first sensor here, and this is just noise, and you can don't see on this one because this is not sensor. This special, I don't know, flashlight which don't give you some information about environment, but this flashlight can give information to environment, and how we can make some interesting things with this flashlight. So I delete all this program, and we have two blocks. We have two blocks here. So we can turn robot LED in position 1, and we can turn robot LED in position 1 off and on. And inside robot, we have a button. Yes, and this button, robot start button pressed. So if I click on this button, you can change the statement of this button. So I go to control and use forever cycle. So after that, I use if else condition here. That's one. And inside this if condition, I put robot start button pressed. If pressed, we can on this LED. If we turn robot LED off, we can off LED. Okay, that's one and that's one. Easy program, easy. So let's start this program. And now I see on this robot, nothing happens. And I put this button. Oh, you don't see this, yes? Yes. Okay, let's show you my camera view. That's one. So now you can see nothing happens. And I put this special button and ta-da! Magic, magic. Ta-da! Еще. And again. Ta-da! Ta-dam, 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 ta-dam. And you can create any conditions for creating for on this LED or off this LED. For example, maybe you have two robots and these robots can communicate with each other with lightning. And this is the good way for our next task. Interesting. So we have not only a distance sensor, we can special light sensor, and we can take some information from light sensor. And I can show you how we can use this sensor. So how light sensor is look like? This is look like here. This is the sun. Yes, you see the sun? Yes. And I can put away and put the sun here. So, and let's see some information from this sensor. And now you can see information is 4. Yes, it's a very small number because I have light here in this room, but it's not bright. And I can show you again camera, and I have special flashlight, and I can turn this flashlight on, this one, and now we can see how change information. So, and yes, you see 100. So we can change information from 4 to 100. Yes, and that will be 45, maybe 20. So you can see how this sensor can take information from my flashlight. So, and let's create some kind of task with this light sensor. So I can hide camera. And for example, we can create, I don't know, vampire robot. Yes, this robot can go away from this light if this light have big numbers. And I use forever block here, and I can use block here if else. After that, I will use an equal operator here. And for example, if our light more than 80, yes, 80, where is it? Yes, correct. That's one. So, and if our robot sensor one more than 80, we can go back. So we can go back with the small steps. For example, motors on for one step, and we can change direction backward. Okay, okay. So I can put this thing here. So let's start. And I can show you screen. So let's check. Nothing happens. Why? Because we don't using set motors power. 100% here. So let's try again. You see this? And huh. And you can see how robot go back with this flashlight. So let's go forward. Okay. So, but of course, we can create some kind of multiple conditions. Yes, here we create only one condition. Yes, if our flashlight have very good brightness, and we can turn back, for example, but we can create many steps of this program. We can create many conditions here. For example, we have big range from 0 to 100. And for example, from 80 to 100, we can go back. But for example, from 50 to 80, we can turn I don't know, right and turn left. And we can create many interesting cases here. For example, let's create cases when robot go right and go back and go right and go left if we have range from 50 to 80. So let's duplicate this block here. And here we create the condition from 50 to 80. Yes. So how we can do this? We will use not only the unequal operator, we will use logical operator here, and we can go to operators, and we can use, so and, not and, or, not or. So we can use and, of course, because we need two conditions. Yes. So if you know how mathematics works, you can see this. And for example, we need two conditions here. So the first one, if our robot sensor less than 80, yes, we can just change this block here and put this thing here, duplicate, and put this block here. Oh, so yes. So, and the first condition, if our robot sensor less than 80, but more than maybe 50. And put this block here. But what actions we will do here? We just delete this block. And you remember we create these conditions to the previous task. So we just using turn block, turn left, and turn right. So again, and put this thing here. So, and let's check how this thing is working. Where is video? Video. Yes, this one. And run this program. So, and now you see sensor information here. So this small number, of course, but I think you can hear it or see this. And when we go to now 40, 13, 40, yes. But if we do this, so, and you can see now this robot go back. So, okay, let's give some rest to our robot. And the last one, we have some kind of range, yes, from 0 to 100, I said about it. And we using range from 50 to 100, but we don't use any range from 0 to 50. And now we will use this range, for example. And how we can use this range. For example, robot just go forward, and after robot found light, yes, robot found light, and after that robot do some action. So, and these actions we create now. So we go right, left, and we go back. So let's create the last thing. So duplicate this code. Here we can just, if our sensor less than 50, yes. Oh, no. Stop. And robot just go forward. So we turn motors on for one step and set robot direction to forward. So this block we will delete. And let's check how this robot is working. So it's one. And I put a light instead of robot, in front of robot, I think here. And let's start. Oh, no, we go away. Oh, sorry. And after that, we can stop program. And for today, I think that's all. So what we learning today? So we learning. Wait a second. Yes, this one. Let's chat with Mr. Robo Platform, and we create chat with Robo Platform. We learning some kind of commands in Scratch and how we can use this command with speaking with robots. And we now learning what's dialogue with robot. This is the uh, looks like our dialogue with each other, but know we must know language and this special language for robots. This is programming language, and we create some kind of interesting task with robots. So we use information which robot use from environment, and we will use this information for creating programs. So thank you very much, and good luck to you for your tasking in Olympiads, and bye. See you later.
Hello and welcome to our Olympiad stream. My name is Andrei Luchin and I am teacher from Robot Club Helsinki in Finland. And today we are talking about robots and robotics, but in this workshop, we will focus on one particular aspect of it. But before we start, I want you to get prepared for our practical assignment. And for that, we are going to use Tinkercad. If you've never been to this webpage, please get there. And it is www.tinkercad.com. And there you can click Start Tinkering and create a personal account. If you need help with creating an account, you can ask your parents or other adults nearby. And that's what we do after we speak about robots. But what a robot is, people have actually been inventing different devices since ancient times. For example, Leonardo da Vinci invented a mechanical knight armor, which could move its arms, neck, sit down, and even open the mouth. So it was a functional device, and a copy of it is in the Milan Museum. One more device from times, and that was in 18th century. It is the scribe, an automatic figure of a boy. It contains about 4,000 parts, 4,000 different pieces, and it is able to write any text of 40 characters independently dipping the pen into the inkwell. Looks great, isn't it? So, but then we get to modern times, and there are many different robots nowadays, and maybe some of them you know, but not all of them are actually robots. Please think of which of these things are robots and try to identify them, and write your answers in chat. Which of these are robots and what picture does not show us a robot? So while you're writing, we will continue with the definition though. So the devices around us are mechanical, automatic, or robotic, but how are they different? And what makes a robot a real robot? So, mechanism is a device with which a person performs physical work, or it can be a moving part of a more complex device. But the simplest ones are a lever or a wheel, for example. Then an automaton is a more complex thing. It is a device that can operate according to the program included in it. Everyone knows a mechanical clock, and it is a good example of an automaton. And then we get to the robots. A robot is an automaton also that can navigate in the environment. It can also make somewhat independent decisions because of the artificial intelligence and because of the information it gets from the world around that helps it to make its decisions. All right, we are back to this slide, and let us read what you've written. Any ideas? So for sure, not all of them are robots. And as we discussed earlier, clock is an automaton. What about this mechanical dog? Would you call it a robot? Or actually, it is quite a simple toy, and it is not real robot. It is a mechanism that does certain function. All right, a vacuum cleaner robot. Yeah, it claims that it is a robot, and it really is. It has sensors to navigate around your house, and it can do its job quite independently. And that's what's important for robots. How about these guys? Are these the robots we were looking for? Great. Okay, let's read some answers. The Gray Flat One and Star Wars. All right, I think it was about the vacuum cleaner robot. And robots from Star Wars. Well, it's a tricky question. They are and they are not, because in the film, they are robots. But, well, while filming, they are human actors, just using costumes. So, thank you for your answers, and let's move on. The next thing we are talking about is, what do all these things have in common? How are they similar? So here we have a light bulb, a vacuum cleaner, a robot, a plane, a laptop or notebook, depending on how you call it, and a smartphone. Please give your ideas. What makes them quite similar in how we use them? Any ideas? Well, they are all modern devices, well, quite modern, some of them older, some of them newer, but the idea is that all of them use electricity to function. And that's what makes them that similar. But if you ask what electricity is, well, we use it in everywhere in the modern world, but what it is, not everybody knows really, and we have the answer. It is quite simple one. They are very, very, very small particles that travel through wires at high speed. And these particles, they give us that energy. And today we are going to focus more on electricity and circuits, electronics, circuit designs. So what circuit engineering does, it works with all kind of circuits that we use in different devices. It is a scientific and technical field that deals with designing them, creating them, debugging them, and all kinds of electronic circuits. They contain smaller parts that are electronic components. And if you want to know how to manage them, you need to study circuit engineering. And today, we are going to get familiar with the very basics. And there is a large theoretical base behind it, but we will do a few simple experiments. So circuit engineering studies principles and how they electronic components or parts are interconnected and what special parts are used. To begin with, we are going to try quite a simple circuit. We are going to take a light bulb and a power source, or well, it's going to be a battery, a power supply for our circuit. And we are going to use a couple of wires for that. So if you happen to not have a bulb and a battery nearby, we have Tinkercad to help us. And it's time to get to Tinkercad now. Hopefully you have an account and it is ready for working. So we are in Tinkercad, and once you get there, here on the left, you can click Circuits. And there is a green button, Create a new circuit. You can click it immediately, and you get in the environment that we are going to use today. So, hope you are in there, and let us build the first simple circuit. So here we are not going to use a light bulb, but an LED. It is basically the same. So you can find it here on the right. Click it and then drag and drop it to the center of the screen, the working area for all of the builds we are doing. So we are going to take an LED and a power source. For an LED, it is enough to have a smaller battery. So we'll just take a coin cell, 3 volts coin cell. And we are going to connect them. But how do we do that? We need to check what are the contacts on the cell and on an LED we have. So here we have a straight leg or cathode, which is essentially a negative contact or a minus sign, if we call it that. So we take a wire from here, click in this leg of an LED, and put it to the negative contact of our coin battery. You can move it around to see the wires better. They are not going to disconnect. They are going to move around with the whole construction. So it's fine if you want to replace it somewhere else. Then an anode is the positive or plus contact of an LED, and we put it to the positive or plus contact of our coin battery. And it is basically it. Our first simple circuit is done, and to make it work, just get to the right top corner of the interface, and here we have this Start Simulation button. Click it, and it turns immediately on. The LED lights up, and the circuit is working. You can start and stop simulation as many times as you like, and you can even move it around a little bit while it is working. And so we covered the basics of how we work here in Tinkercad circuits, but that was only the beginning. We are going to try a way more complex automated circuit. So back to discussing what parts we use for that. And first of all, we are going to use an Arduino Uno board. It will help us study the circuitry. It is used for creating simple and not very simple automation and robotics system. And you can connect different sensors and motors and screens to it and program them, even program them. With this board, you can do everything from flashing lights to 3D holograms and even robots controlled from your smartphone. Let us look closer at what we have here. The basic components are the microcontroller. So it is the brain for the board, and all the programs and all the actions are processed there. Number two is board for connecting it to a computer. So it's through USB. Then the third one is power connection port. If you want to have a separate power supply, for example, a battery box for your Arduino, then you are going to use that connection. And then we have all the different pins for connecting external devices. And we are going to have a closer look at these pins because we are going to use them right away. On top of Arduino board, there are control pins. They are digital pins. And they are actually used to give signals to external devices we connect. Then here on the left, we have power pins or direct current pins. And for example, here we have 5 volts pin. It is kind of a plus on the battery. It gives us energy constantly. Then we have ground pin, and it stands for minus or negative contact. And then we have analog input pins. We are going to use them to get information from external sensors in our system. And the thing we are going to try out is a simulation of a musical instrument called the theremin box. It is made of electronic components, and it allows us to change pitch of the sound in non-contact way, more or less blocking the photoresistor from light. And the original instrument was invented in 1920 by Lev Theremin. And now we have the opportunity to reproduce it using an Arduino board. So here is the circuit diagram of the theremin box, and such schemes are used usually to show what parts or electronic components we need to use. And we are going to check which ones we are going to use. First of all, we need a piezo buzzer. It is a small speaker that translates electrical signals to sound. And as we are talking about musical instrument, that's what we are going to use for sure. Then a photoresistor. It is also known as light-dependent resistor, and it decreases resistance depending on light around it, thanks to its light-sensitive surface. And we are going to use a bunch of wires to connect all the components. Let us have a closer look at the scheme. Here we have this piezo buzzer. So its negative contact is connected to the ground pin of Arduino, and its plus pin is connected to digital pin number 3. Then we have a photoresistor. It also needs 2 connections to A0 analog pin and to the ground or negative contact for our circuit. And we're going to add one more resistor that will help us to say the components and adjust the signal. It's time for experiments. Get back to Tinkercad, please. And let us create the circuit. The components we are going to use can also be found here on the right. And as we discussed, which of them are needed, you can just drag and drop them to the working field. We will find use for them a little bit later. So a piezo buzzer, a photoresistor, and an Arduino board. Yeah, it was the first one we covered actually. And a resistor. So we could have connected them all with simple wires, but if we are talking about creating a real life model, it is not going to be that simple. So for that, we are going to add one more part, which is a breadboard. So here is how it would look if we create it with our own hands in a real world. So there is a whole lot of wires used. And to connect them all, we are going to use breadboard. So let's begin with placing the components first. So a buzzer. Just make sure that the contacts get in the holes on the breadboard. Then we are going to place a photoresistor down here. And a resistor. It's going to be close to the photoresistor here, but we need to rotate it a little bit. And in the top left corner, there is a rotation button. Please click it a few times so that our resistor is in the horizontal view. And we place it just a little bit below the photoresistor so that the contacts are on the same line. So if you use your mouse to you can place it over the breadboard, and it shows that all the pins are in contact, all of them with the 15th mark here. So the parts are on their places, ready to go, but then we need to connect them all. And as we checked on the electrical scheme earlier, we need to connect 5 volts from our power source to our plus line on the breadboard. And we need to connect negative or minus contact to our minus contact on the breadboard. Then we are going to use different Arduino board pins for connecting other components. And as we need signal that is going to go from phototransistor to Arduino, because analog pins are input pins, the signal is going right from pin 15 here on the breadboard and goes to A0 analog pin in Arduino. And for our piezo buzzer, that is going to take signals from Arduino board, we connect its plus contact to digital pin 3. And what we have left to do is adding a few more wires to connect our components to negative line for piezo buzzer. So it can get here, for example, and negative contact for our photoresistor. So you can just connect it close nearby, but to our negative line down here on the board. And what's more, we need plus connection for our standard resistor. And the circuit is basically ready. You can try and start simulation and check if anything happens. And it seems that nothing does. But why is it? Well, the Arduino board does not know what to do yet because we did not use any program for that. So it needs to be pre-programmed, and for that we get to code. So once you open it, you have a few blocks here already, but we are not going to use them. You can drag and drop them all to the trash bin. We are going to create our own program. And let us think of how we do it. So we actually need to give signal to the piezo buzzer. So this third pin is going to be our output pin. And for that, we take this set pin 3, and we have a variable here, but we are going to replace it a few seconds later with other numbers, because we are going to actually get an input signal to our Arduino board, and it's going to be our analog pin 0. You could try and place it there just like that and check if it works. and it does work. But now it is all about experimenting and adjusting numbers. And if you start simulation and click this photo resistor, here is the light level, and you can adjust it to change the sound. Make sure that you have sound on your computer on, otherwise you are not going to hear this buzzer. And try to start simulation and change this slider a little bit, move it left and right. So here it stands for dark or no light. And here on the right, we have bigger light level. We can change sound a little bit more if we add some math blocks here. So that's why we can change the range at which we actually work. And so we are going to use this very first block, and we are going to change this sign to dividing it. Then we are going to divide the input values we get to our pin by, for example, let us say 10. And you can put this back to the block we originally used. If you start simulation now and use the slider again, you are going to have slightly different sound pitch. And we can even more change it, because these values can be adjusted from, let's say, 10 to up to 80, maybe. And you can check now. So feel free to do your experiments with changing the values and check how it works. Well, another value you could possibly change is our standard resistor we are using here. You can add some values here, because actually the range we can use here is not unlimited. It only takes a few grades or steps of signal, but using this resistance value of our resistor, you can change it further. And you are going to get different sounds. So that's an extra task, adjusting the resistor. What if we change 10 kilo ohm resistor with a resistor of 100 kilo ohm? You can try that too. And that's how it works. In real life, we do not have such a slider, but we would just use our palm, for example, to cover the light sensor, the photoresistor we have here, to change the sound. Or we are going to use a flashlight to add more luminosity, and then it is going to give us different sound again. You can even find videos. Well, if you just look for them on YouTube, for example, that people use this quite simple and at the same time quite advanced, because it includes circuits and electrical components, musical instrument for producing some music or playing it actually. And that's a great example how circuit designs and different circuits let us create automated systems that get information from the environment, like light level in our case, and they give us back another signal, which is sound. And it is used in robotics, well, basically everywhere. So robots use light sensors, they use other sensors. Well, we already had a few examples on our previous workshop. And they really use many sensors and many circuits. And if you want to be successful as an expert in robotics, you need to know how the internals, the electrical parts and components of robots work, how they interact, how to connect them, and how to make them work together, resulting in an effective and functional system. That's all for now. Hope that was good experience and you learned something new and interesting. And good luck with your future studies on the field of robotics. Thank you for your attention. Have a nice day. Goodbye.
Hi, my name is Svetoslav.
Hello everyone, welcome to our amazing Blender stream. My name is Olga Savilyeva, and today we will learn about the functions of the Blender program. We will also create a model and materials for that model. Before we start talking about the program, let's repeat the basic terms. A 3D model is a three-dimensional digital image of some object. It could be a real object or fictional. 3D modeling is a process of creating a three-dimensional model of an object. And 3D modeling can be used to create real objects. For example, in our Robbo clubs, children learn to create models that are then printed on 3D printer. It can be some useful or funny or some animals, anything you like. But also, using 3D modeling, you can create some beautiful images which will never printed. For example, models for video games. Now I want you to text in chat if you play video games and would you like to make models for video games by yourself sometimes. I give you 15 seconds to do this. Well, of course you do. I think most of you would like to do some models because it's very interesting. Well, the Blender program can be used both for both engineering and the artistic modeling. So what is it, the Blender? Blender program is a professional, free and open source software. Do you know what does it mean? Yeah, that's right. This means that we can use this program completely free of charge. And it's very, very good for all of us. However, the program is very popular not only because it's free. Blender has a huge number of functions. The main functions are listed on the slide here. It's 3D modeling, of course, but also creating an animation, sculpting. It's when you like making from the clay, from the digital clay, a face of character, for example. You can make some realistic effects and also do some post-processing and rendering to make your picture look amazing. If you're interested in Blender, you can download it from the official site. It's www.blender.org. But I suggest you not to do it right now because it's complicated program, and I suggest you to download it later after our stream, after Scratch Olympiad, and to try to do your first steps in this program after that. And in the next slide, we can see that the things that we can use, that we can do in the Blender program. Just look at the in this picture, you can see it's some first steps of creating the mountains, creating the clouds, and here down we can see another picture, and this is the final render of these mountains, and everything you see was done in Blender. These images are frames from a cartoon that was made totally in Blender. Its name is Spring, and you can find it on YouTube also after our Olympiad. It's also very interesting. And you can see here that on this image, also some first steps. You can see that all these black lines are animation lines, which helps a character to move in the cartoon. And on the down image, you can see a final render of this frame. And I think it's very impressive that all the light, all the materials, all the sculpting can be made in just one program. Next thing is also very important. It's very important point. Do you know what are selected parts of these shapes called? It's three names for the cube and the same three names for a pyramid. These terms are very important to know because we will use it when we will work with the program. I will give you also some time to remember, and if you knew these names, then text it in the chat. But for some of you, it could be some new terms, and it's okay. I'll give you a few more seconds to send your message. Yeah, I see first messages. Great. And you're absolutely right. It's edge, face, and vertex. I want you all to remember these terms, and then we can go to the next slide. Now we will talk about a polygonal grid. Well, what is it, polygonal grid, and why do we need it? Is a set of vertices, edges, and faces, we just talked about it, that determine the shape of any polygonal object. It's polygonal because it consists of polygons. Polygons are flat shapes that make up an object. So any object that we make in Blender consists of small polygons, small flat shapes. Modeling can be low poly, medium poly, and high poly. Let's look at the picture that we see on this slide. And I want you to try to guess which of these three models is low poly. I will give you also a few seconds. So here on the picture, we have also low poly, medium poly, and high poly. So which of these pictures is low poly? Well, I think you already understand that, yeah, and I see also the answer in chat. Thank you, Gleb. The first one is low poly because it's so rough, you know, and it contains the least polygons. And the model in the middle do you think it also consists of polygons? Yes, of course, there are just so many polygons that we can see some individual ones, but it also contains the polygons. Let's go to the next slide, and here we can see images. Maybe it's a photos. What do you think? It's not a photos, it's images, and these images also were created in the Blender program. And if you will work hard, then you also can create such models. And of course, it's not models only here, but it's also light, camera, and a lot of other things. So you need to learn how to create, if you want to learn how to create such images, you need to study for a long time. I will not lie to you, it's not the first steps in Blender and you have such a picture. But I have a good news. Because we have such a style as low poly. And low poly is very popular because it's great for beginners. And actually it looks very nice. It not looks like something bad or poor. It looks also very atmospheric and cute, I think. Well, I think now we are ready to start working with the Blender. I will show you some tools and I will show you how to create your individual special materials. So here is a Blender program. And this is what you see when you're just starting a new project in Blender. Just a simple cube, and also we have here camera and the light. I will delete the camera and the light, and it will be the first instrument. It would be delete instrument. And also I will add some special add-on. And now you can see everything I do here in the down right corner. So for example, I'm pressing X. I will use hotkeys today because it's much more faster and easy to use hotkeys, but not all these sets of the instrument from the different panels. So I'm pressing X to delete the camera, and I'm also pressing X to delete the light. And now I've got just one cube. Now I will tell you about three main instruments, three main tools in Blender. It's instrument scale. Instrument scale is using for changing size of different shapes and different objects. You need to press button S key, and you see now we're changing the size of the cube. Then I will tell you about the tool which help us to change the place of our cube. To use it, you need to press G. Let's try again. G. You can see here in the corner, you can see all the actions that I do. So G is to move. And the last one is rotate. You need to press R to rotate our cube. And now will be maybe more difficult information for you. Because when you press in G, and then it would be you can use different axes. So I can move it to the axis X. When I press in G and then X, I can move it on the Y axis and of course on the Z axis. And the same thing with the scale and rotate. Let's look fast. So I can scale Z, I can scale X, and I can scale Y axis. Well, it's the main instrument, and actually in Blender there are tons of different instruments. So the other ones I will tell you in process of creating our star. Today we are working with creating a star. It would be glass and it would be glowing. So I'm adding some additional object. I deleted our cube, and to add additional object, I'm pressing I'm pressing Shift A. And now I have this menu and I can choose the object I want to add. Now I want to add a circle, a flat circle. Here we also have a sphere, but now I need a circle. And it would be not just a circle, but I will want also change some preferences, change some settings of the circle. So it would have 10 vertices. And it would consist of small triangles. So I'm changing fill type from nothing to triangle fun. So now you have this circle. But maybe you will say that, well, Olga, you told about the star. It's not a star. Just a second. Next step is we're going to the edit mode. Blender has a few modes. Now we are in the object mode. So in object mode, we're working with a few with the objects, just with the full object. And if you want to change the shape of object with working with faces, vertices, and edges, then we need to go to the edit mode. And to do it, we can press here and change it from object mode to edit mode, or we can press tab. So now we are in edit mode, and you see that now we can see all the vertices of our circle. And also we can here choose edges, and now I can choose the edges and the faces, and now I can choose the faces. But let's return to the choosing of vertices. And to make it more comfortable, I will press 7 on numlock. The numbers of the numlock are using for changing the view of your camera. So how do you look everything what is going on this viewport? For example, 3, it's view from the side, and as well as 1 is the front, and the 7 is from top. Next step is we need to choose the vertices. One we choose and one we miss. One we choose and one we miss. So now I chose 5 vertex. And then I'm pressing S, scale. And now we can have a star. We just change the size of these vertices. We actually removed it, but this is how it works in Blender. And now we have this fantastic star. Maybe I will do it even more. Yeah, something like this would be okay. But our star is still flat. So I'm choosing all the star. To do it, I'm pressing A key, and now our star is totally chosen. It's totally selected. And now I'm using another instrument as extrude instrument. If you ever worked with the 3D modeling in Tinkercad, for example, it's not only a program for the circuits, but it's also, I think, the most popular program for the children and for the beginners for 3D modeling. So there we also have an extrude instrument. So now we're pressing E to use this instrument. And you see, we are extruding our star in any side we like. Something like this would be perfect, I think. Next thing is I want to add some additional volume to our star. So I am choosing the center vertex and from another side, because I want my star to be to have some symmetry. And then I will use also a scale instrument, and a scale not in any side, but scale to Z axis. Let's look. Maybe a little more. So I'm using this instrument again, S, Z, like this. So now I have a star, and it's not flat, but it looks now a little too simple. Don't you think so? So now I want to use next tool, next instrument, and this instrument's name is bevel, and its and key for this instrument is Control B. What doing this instrument? Let's select all the edges not the vertex, but edges. I changed the mode here. So it's edge select. And I'm choosing all the edges we have by pressing A. I already told you about it. Then I use instrument, Control B, as I told you. And let's look, what does it happen? Instead of all of our edges, there are some additional faces. And now it looks more complicated and more finished. Let me try again. Selected all the edges, pressing Ctrl B. And now I'm choosing how much intention of this instrument I want. So something like this would be perfect, I think. And everywhere we had just one edge, then we now have 2 edges. So we have all these additional faces. I think I finished with the star. And now I'm returning to the object mode. I can do it here, but I will just press Tab. And this is our star. What will be next? Next thing is I want to add some handle to my star. But why star need a handle? Because it would be not just a simple star. I want to make it a magic wand. So it would be a magic glass wand. And of course it will be glowing. And the wand need a handle. It would be just a simple cylinder. Why? We don't need something complicated here. And actually it's one of the main rules of 3D modeling, as I think. Maybe you are not agree with me, but I think that if you can make something simpler with no and not to do your image worse, you should do this step and make it simpler. Because the most, if you have a lot of details, then it's bigger chance to make some mistakes. And if you have something simple, there will be no mistakes. I think it's clear. So let's add the cylinder. Also also Shift A, mesh. And by the way, do you remember what kind of mesh is it? And why is it mesh? Yeah, it's polygonal mesh. It's one of our main terms today. So mesh, and here we selecting cylinder. Now our cylinder is not looking the way I like to. So I want to change its size, its scale instrument, pressing S. And I want to make it more longer. So SZ. I'm changing the sizes again, but only in one axis. Pressing 1. Or yeah, 3 would be better. So I pressed 3, and to make it more easy for us, I will press 5. It's orthographic mode of view. We have a panoramic mode. It's just like we see it in real life. And also we have orthographic mode, This mode is using for us to easily creating some objects. So it's not like we see it in real life. There's no changing depending of the place of your objects on the viewport. So I'm rotating my handle now using instrument rotate, its R button. And 90. We can also use numbers. And I want to move it, so it's G button, G, Y. Let's look, what do we have now? Oh, actually, it looks like a magic wand. Magic wand, actually. But there's one thing we forgot. What is it? It's a materials, and it's another big folder of knowledge about the program. And I will show you something, not so much things, but it would be interesting. So we need our magic wand to be glass. How can we do it? To do it, we need to do a few things. First of all, we need to separate our screen. Then you need to place your cursor here. And when you see two arrows like this, you need to press right button mouse and choose vertical split. So now we splitting our screen, pressing somewhere in the middle of the viewport. And now we have few, not few, but two. We have two individual viewports. In the left one, we will work with, we will see the result of our work with materials. And to do it, we need to change the view mode. Now it's, now this mode is solid. And how did I do it? Done it? We need to press Z. And here are few modes for view modes we can choose. It's solid mode, it's wireframe mode, and material preview and rendered. We don't need rendered now because, well, to be honest, we don't need any camera or light today, so we will not make any render, so forgot about this mode. Now we are in solid mode because all our shapes have no material, and we can see it. How does it look? Also, we have wireframe mode. Press, and now we can see only our polygonal grid here, but we don't have any faces. We can see only vertexes and edges. And now we need the last mode is a material preview mode. Pressing here. Now we have our star. It's white because it doesn't have any materials now. So in the right viewport, we are going to the material properties. And here we are going to shader editor. Need to press here and choose shader editor. We don't have any materials now, but we will add it right now. Here we will use the system of nodes. Nodes are the tables using which you can to create your special material. So adding new material here, deleting using X this big node. It's like in Scratch. We will combine some blocks, some nodes to create something unique. So to do a transparent material, we need to add a few nodes. First one is mix shader. This node we're using for mixing some another shaders. And we want the surface of our star to be glass, to be transparent. But which nodes will we mix? It would be transparent mode, not translucent, but transparent. It's important. And also it would be glass mode. And one important thing is we need to change here in the right menu, blend mode from opaque to alpha blend. And I will also change this number here in the glass node. Something like 10 would be okay. And look, it's already glass. And I think now you understand why do we choose this instrument like a bevel, because all these faces now are so shining, and we even didn't added any shine, but it's already shining. So our handle, and also we can change this number in mix shader. I think something like this, like 0.36 would be all right. Now I want my handle all have the also material. It's material number 001. So I am selecting here our cylinder and choosing material again. So now our star is absolutely glass. Beautiful, isn't it? But we also want to make it glowing. To do it, I will copy my star, make it smaller, and add some additional material, and we'll make it glowing. Well, now I'm pressing Ctrl D to create the copy of my star. Now, then I am pressing S to instrument scale to make it slow, make it smaller. Not that smaller, something like this. And now I need to create some additional material. Selecting this star, this small star, deleting this material and adding some new. Here I need this bigger node. I will not delete it. And I am also selecting mix shader here and additional emission. Not this one. Emission. And selecting a color yellow, bright yellow, and strength like maybe 9. And I also connected it. It's too much, I think. Like this. So now our star is glowing. We have a magic wand, and I think it looks very nice. Let's see it closer. And it would be the end of our masterclass. This is the final of our work. And I hope that you will interested in this thing. We have lesson of Blender in our Robot clubs. And of course, you can try to do it yourself. And I wish you good luck and bye-bye.
Смотрите, когда я буду. Thank you everyone for participating in the Scratch Olympiad translation. As usual, you know that you can always find us via email and on Facebook if you have any questions about the tasks. I will just remind you that the deadline for the task is quite soon, September 27th for the Scratch discipline and October 2nd for the Scratch plus Robbo discipline at 9 a.m. UTC. Please check the right time for your country. I'm So thank you so much for participation in the translation of the final stage of the Olympiad. I hope to see you again next year as a participant. Again, please don't forget about the deadlines. It's 27th of September for the Scratch discipline and the 2nd of October for Scratch plus Robot discipline. You will find out the results on October 12th. So I hope you have fun doing the tasks and you had fun listening to the workshops. See you.